Good morning. And after much inhibition to get off this brief lecture on solar power engineering and solar energy, I sort of finally got the opportunity to just briefly address solar power engineering, solar energy. Yours truly, Dolphy Gilpin, is here this morning, and I've taken another brief aside from my medical research just to put in some solar power engineering work. My AMZ5X12M I matrix, PDM, is here, and I quickly now introduce my 5x12 matrix with parameters as representing solar. But let's just say now A, B, C in general, D, E, F, G, H, I, J, K, L, M, N, O. And for internal parameters now, we have S solar 1, S 2, S 3, S 4, S 5, S 6, S 7, S 8, S 1, S 2, S 3, and here my marker is giving way. I have to change my marker. S 4, S 5, S 6, S 7, S 8. And since we represent the S as solar, I'm just going to use the word solar. Solar 1, solar 2, solar 3, solar 4, solar 5, solar 6, solar 7, solar 8, solar 1, solar 2, solar 3, solar 4, solar 5, solar 6, solar 7, solar 8, solar 1, solar 2, solar 3, solar 4, solar 5, solar 6, solar 7, and solar 8. This is in the configuration of the AMZ5X12M matrix. And once again, we have since we solar, B solar, E solar, H solar, K solar, and N solar. And now since this solar project or solar power engineering work will be extensively used, we are going to introduce a stochastic matrix. This is just a 5x11, 5x12. A stochastic matrix that can take us out above 5x12 into other region, and we call that a stochastic matrix. But we'll not write that down. We'll start from our basic 5x12 matrix and PD. And we're going to skip now and go to another process, some intermediate steps, and we're going to skip to a 2x2, in which we have now S 1, S 2, S 2, S 1, S22. By breaking them just using the PNM processing, we'll come to some 2x2s. And so we just do this. So we're going to introduce some simplicity here. As simplistic as the sun shines without us ever even consciously thinking. The sun shines in us, and God, the good God, sent down this energy, solar power energy, onto us without. All we have to do is to take a clean breath, and we have our energy, solar energy. So I'm introducing some simplistics. I'm going to the simplest form here, the 2x2. Right? So if we take the determinant of this, we have now S11, S22, minus now S12, S21. And we're saying now that all these parameters will be in solar parameters, solar voltage, solar current I, and solar resistance. And this will be equal to some number in voltage, current, and resistance. So for example, if we substitute now S for say 5 volts, S11 equals 5 volts, S12 equals say 7 volts, S21 equals 3 volts, S22 equals 10 volts. And what we'll have for this would be S11 times S22 will be 50 minus now S12 7 multiplied by 21 3. That's equal to 50 minus 21, and that will be equal now to 29 volts. And so we're going to do, just for simplicity, as an exercise in this 2x2. This is independent now. We say S11, solar parameter S11, S solar parameter S12, solar parameter S21, solar parameter S22. And suppose if we have some current independent of this, where S11 equals now to say 5 amps, S12 equals to say 7 amps, S13 equals 10 amps, S21 and S22 equal to say 20 amps. And so we have know that if we take the determinant of this now, this is independent of this, this would be voltage solar, this is current solar in amps. If you work out this one separately now, we have the determinant 2 by 2 would be S11 multiplied by S22 minus S12 multiplied by S21. And that's equal now. We substitute the values here. S11, 5 multiplied by seven, S11 times S22 multiplied by 20 minus S12, 7 S21 multiplied by 10. And that's equal now to 100 minus 70 equals to 30 grams. This is just turn out to be an exercise in determinant of some 2 by 2. Remember now we have left out the intermediate steps of breaking down the 5 by 12 until this reaches the 2 by 2. And so we'll have 30 hours. Okay, so we just make some other substitution here now. This is an exercise in 2 by 2. Solar parameter 1, solar parameter and we substitute some parameters now. Could have said this one for resistance. I would say resistance solar S11. Say we have now ohms, 10 ohms. S12, this is a resistance matrix. 5 ohms. 8 ohms. 12 ohms. And what we'll have, simply S11, and this is resistance. When you take the determinant D, would be equal to S11 times S22. So it's 10 multiplied by 12 minus 8 multiplied by, well, S11, S12 would be equal to, say, 7 ohms. So that would be equal now to 120 ohms minus 56, that's equal to 44 ohms. This is just turned out to be an exercise in 2 by 2 determinants, and finding their not partial determinant but full scalar determinants. So we could continue by just doing exercise, arbitrarily substituting some solar parameters here in voltage, current, and resistance. And then we could return to some inductance and capacitance and make some calculation. But for the moment, we will just take the basic tree, which is the voltage, current, and resistance. We'll take a break from here and then return with some solar energy calculation via matrix determinant. As we are returning at 1524 LaVista Drive, Decatur, Georgia, United States of America, we are continuing with our solar power and solar energy engineering. And we have introduced our matrix 5x12 matrix and PDM processing, and this is it. The only difference is that we have used the term S representing solar now, and this is the matrix, and that is it. Now we're going to try to, in our determinant now, D, we have, as you know, left out a lot of intermediate steps in the processing to reach the 2x2s for simplicity. And trying here now to get some voltage in the region of also voltage, which would be like 120, 150, 120. So we have now S, solar 1, 1, say, solar 1, 2, solar 2, 1, and solar 2, 2. And this is like for voltage now. And we say that, let's say S11 equals now to 200 volts. And that S2 equal to say 5 volts. And that S12 is equal to say 2 volts, and that S21 is equal to 3 volts. And so we find the determinant by plugging in these values, solar values now, and we say that the determinant of this matrix will be now S11, S22 minus S12 and S21 in solar parameters. And so this is now equal to, we make the substitution, you know, S11, 200 volts, multiplied by 5 minus S12, 2 volts multiplied now by 3 volts. And that would be equal now to 1000 volts minus 6 volts. That's equal now to 996 volts. So make some other substitution, you know, we have S11 now equal to say 100 volts, and S22 equals to say 1 volts, S12